Now today we are going to discuss about memory management. So for example, if you want to execute any program, definitely the program should be reside in the main memory. So just I will explain you first what is the general process of executing a program. First, the user will write the program in some high level language. After writing the program in some high level language, he has to compile the program. Okay. Now after compiling, we are going to get the object code. The object code will be in the form of zeros and ones. Now this object code will be kept in the secondary memory. Assume that this is a secondary memory. Now this is a secondary memory. This object code, whatever things we have get from after compiling, we are going to get the object code. The object code will be in the form of zeros and ones. Now this one will be the object code. Now if I want to execute this object code, first of all this object code must be brought from secondary memory to main memory. This is the main memory. The CPU will have access only to the main memory. If I want to execute any program, the program must be brought up into the main memory. Then only the program will be executed. Now we may get the doubt that why CPU has to bring the program from secondary memory to main memory. CPU will have access only to the main memory. CPU will not have access to the secondary memory. That's why for every time if I want to execute any program, the program must be brought into the main memory. Who will do all these things means, for example, if I want to load the program from secondary memory to main memory, so that operating system will checks whether the main memory is free or not. If the main memory is free, then only the object program will be loaded into the main memory. Operating system will be checking off whether the memory is free or not free. Then again operating system will checks if the CPU is free or not. If the CPU is free, then the object code will be loaded into the CPU. Then we are going to see about memory management techniques in operating systems. Okay. Introduction of memory management. Now I will give what is meant by abstract view of memory. Abstract view of memory. The memory will be organized in the form of words. This is the memory. This is the main memory. Assume that this is the main memory. The memory will be organized in the form of words. This is word number 0. Like this there will be n number of words. Okay, like this there will be n number of words. Now if I want to calculate the total capacity of main memory, total capacity of the main memory will be the total number of words. If there are n number of words, there are total n words are there, so the total capacity of the main memory will be n words. Similarly, based upon the number of words, we are going to calculate the memory size. Now I will give you this general notation of memory size. See, for example, there are 8 words. This is word number 0 and it will end with 8 words, 7. Okay, so total how many number of words are there means total 8 words are there. So total number of words will be represented by capital N. So total number of words. Total number of words are represented by capital N. Now if I want to represent these 7 words, I should need address. So what is the address of 0th word? What is the address of first word? Like this I should know the bits. N we will represent with as N. N is nothing but address bits. Address bits. Okay, next. So each and every word will be having one bit. So now word number 0 we has to store some capacity of the data. So that capacity of the data will be represented by M. M is nothing but width of each word. Width of each word. Now we will calculate the formulas for this one. Suppose total how many number of words are there? 8 words are there. Now to represent these 8 words, how many number of bits are required? So 8 words are there means 8 can be written as 2 to the power of 3. So 3 bits are required as, so n will be as, small n will be 3 bits. Like this there are some formulas how to calculate the number of words, number of address bits, like this. Okay, now I will give you the general formula of total number of words. Total number of words will be represented by capital N and it will be, the formula will be 2 to the power of n. And similarly, if I want to calculate the address bits will be represented by small n. Small n, if you want to know, means log n base 2. I will take one example and I will show you. Suppose if there are total number of words are 8 words. 8 words are there. So to represent these 8 words, how many address bits are required? So n can be represented as n is equal to 2 to the power of small n. Okay, so n is 8. So what I have to keep the value of small n to get 8? So just I will keep it as 3. So n will be cancelled as 3 bits, or otherwise you can just calculate the formula like this: n is equal to log n capital N base 2. So if I want to get small n, log 8 base 2, so you are going to get small 3. We are going to get n as small n as 3 bits. Like this, there are some general notations for each and everything. We will see one by one. 2 to the power of 5 means 2 to the power of 5. If I am having 5 bits, I can use 32 words. Similarly, 2 power 6. 2 power 6 is nothing but 64. So if I am having 6 bits, I can form 64 words. Similarly, 2 power 7. If I am having 7 bits, I can form 128 words. Like this, 2 power 8, 256. 2 power 9 means 512. 2 power 10 means 1024. 1024 is also called as 1k, and 2 power 20 is called as 1m, and 2 power 30 is also called as 1g. Like this. So I will generally conclude this formula by capital N can be represented. The formula to represent capital N is equal to 2 power n. And if I want to calculate address bits, if I know capital N, then the formula will be n is equal to log n base 2. These two are very important formulas, so that it will be easy for you to calculate how many number of words and how many number of address bits. I will tell you the shortcuts how to find out if one is given, how to find out other. Suppose if they have given as 2 power 11. 2 power 11 can be split as 2 power 10, 2 power 1. So 2 power 10 is nothing but 1k, and 2 means just I will guess 2k. Total the memory size will be 2k. Okay. Next, similarly, if they will give you 4 GB, they ask you the total capacity of the main memory is 4 GB. N is equal to 4 GB, and they are asking you how many number of address bits are needed. So it is very simple. First, G is nothing but 2 power 30, and 4 can be represented as 2 power 2. So total how many bits are required means 32 bits are required. So the answer for small n will be 32 bits. Okay. Now see, next important topic is how the memory is organized. Memory can be organized in the form of 3 things. One is either memory can be organized in the form of word, or in the form of block, in the form of bytes, or in the form of bits. Okay. Now based upon this one, the memory will be organized. Now we will see some problems related to how the memory is organized in the form of words, how the memory is organized in the form of bytes, and how the memory is organized in the form of bits. Now we will see that total. We will take one example and I will explain. Suppose n is equal to 23 bits. Means they are saying that I have to represent the memory with 23 bits. Means if I am having 23 bits, how many number of words I can form? Next, similarly, each word having the capacity of 16 bits. Okay. Now I have to organize the memory in the form of words, in the form of bytes and bits. It is very simple. Just see here. Now first I will take it as word. Next, bytes and bits. Okay. Now this is assume that this is the capacity, and this is the address bits are needed. Okay. Now see here, first how the memory is organized in the form of word. Word is nothing but, if I am having 23 bits, how many words I can form? I told you the formula. So if I am having 3 bits means I can form it as 2 power 3. Similarly, if I am having 23 bits, I can form it as 2 power 23. So how many address bits are required? 23 bits are required. So just I will keep it as 23. Next, now I have finished in the form of words. Now next, coming to the bytes. Now see here, one word capacity is having how many bytes? 16 bits. 16 bits is nothing but 2 bytes. Now what will be the capacity means? See here, 2 to the power of 23, that will be in the form of words. Now one word is having how many bytes? 2 bytes. So into 2 bytes can be written as 2 power 1. So just it will be 2 power 24. Now how many address bits are required? Means 24 bits are required. Next, similarly in the form of bits also. Bits is nothing but this entire answer in the form of bits. So first we will take it as 2 power 23 number of words. One word is having how many bits? 16 bits. 16 bits is nothing but 2 power 4. So total bits are required as 23 plus 7 is nothing but 27 bits. So this many address, this is the address bits and these are all capacity of the memory. We will take one more example and we will solve it. N is equal to 256 megawords. Okay. Next, and the capacity of each word is 32 bits. Means one word is capable of storing 32 bits. Now 32 bits in the form of one word. If you want to talk it in the terms of bytes, how many 32 bits can be called it as 4 bytes. Okay. Now see here, just we will write down as in the form of words, in the form of bytes, in the form of bits. This is capacity. This is called as address bits. Okay. Now capacity, they already mentioned it as 256 megawords. So directly write down as 256 megawords. Now to represent this 256 megawords, how many bits are required? M is nothing but, I told you already, M is nothing but 2 power 20. Next 256 is nothing but 2 power 8. So total how many address bits are required? 28 address bits are required. Next, similarly in terms of bytes. Now this entire answer is now in the form of words. Now one word is capable of storing how many bytes? 4 bytes. So just write down as 256 n mega. Instead of one word is capable of storing how many? 4 bytes. So into 4 bytes. Now for this one you have to represent this address bits. 256 is nothing but 2 power 8. M is nothing but 2 power 20 and 4 is that represented by 2 power 2. Total 30 bits are required. Similarly in terms of bits, 256 mega, instead of one word is capable of how many bits? 32 bits. So M into 32 bits. So 256 can be represented as 2 power 8, M can be represented as 2 power 20 and 32 can be represented as 2 power 5. 30, 20, 30. 33 bits are required. Yeah, 33. It will be 33 bits. Next. Suppose next problem will be based on how to calculate number of memory location. Next we will see about how to calculate number of chips are required. So I will give you the general formula as number of chips is equal to desired memory size by memory chip size. Okay, desired memory size by memory chip size. Now for example, they have given the memory size as 512 MB. Memory size as 512 MB and chip size as 128 MB. Now they are asking you, the question will be very simple. See here, now for example they are asking you to consider the chip size of 128 MB. They are having 128 MB and they are asking you to construct of 512 MB. Means for example, if you are having 100 rupees, okay, now they are asking you to form it as 500 rupees. So how we are going to do means just 500 divided by 100. So I have to make 500 rupees to form one single 500 rupees. Same concept, how to make 128 MB. I am having 128 MB memories. They are asking you to construct 512 MB memories. How means just do it as 512 MB divided by 128 MB. So 512 can be represented as 2 power 9, M can be represented as 2 power 20. Next similarly 128 can be represented as 2 power 7 and M can be represented as 2 power 20. Total 2 power 29 by 2 power 27. Total you are going to get 2 power 2. Means 4 memories of 128 MB are required to form single 512 MB. Okay, like this. How this 4 128 memories will be formed means like this it will be there. So just I'll give you the formula like this. So just P is equal to capital N dash by small n, and Q is equal to small w dash by w. N is nothing but words and M is nothing but width. Okay, now so 512 will be divided by 128, and this will be the P, and Q is nothing but 8 by 8. 8 is 8. Why I have taken 8 as bytes is nothing but 8 bits. So just I have taken like this. Okay. Now P value will be 4 and Q value will be 1. So total P into Q. P into Q is nothing but 4 into 1. Means 4 memory chips are required. Size of 128 are required to form 512 112 512 bytes of memory. So how now this how 4 128 should be organized. Now this will be organized like this. Okay, now these memories will be organized like this. So how many number of decoders are needed to form this one? 4 chips are there. So to get 4 chips, the input should be 2 decoders. So it will be like this. Input will be like this. 2 input lines will be there. 2 into 4 decoder is needed. Similarly, if I am having like this, you take it as memory chip size as. Now you take one more example. The given memory size as 128 bytes, and the RAM given and the RAM size is as 128 into 1. So they are asking you how many number of chips are required. Now they are asking you to form 128 bytes of memory, 128 into 1 to form 128 bytes. So just you take P value. P value is n dash by n. So what is n dash? N dash is 128, and what is n? N dash is 128. Now P value will be 1. Next you take Q value. Q value of what is Q? Q value is w dash by w. W dash is bytes. Byte is nothing but 8. And what is the value of w? W value is 1. So Q value is 8. So Q value is 8 and P value is 1. Okay, P value is 1 and Q value is 8. Now how many chips are required means P into Q is nothing but 8 chips are needed. How these 8 chips should be organized now? So since we are having only one row, so that is P value is 1 and Q value is 8. So if the memory can be accessed, if I want to access any memory, entire row will be activated at a time. Since there are having only one row and 8 columns, so all the 8 will be activated at a time. So how many number of decoders are needed means 0 decoders are needed, because at a single time all the 8 memories can be accessed. So 1 into 8 can be accessed by 0 decoder. Suppose if you are having 8 into 1 memories, so how many number of decoders are required? What is the size of decoder means since there are 8 rows can have to be accessed by 3 into 8 decoder. Means if I am having 3 input lines, I can access 8 memories.